In today's video, we will be discussing Ncert solutions of the chapter Some Basic Concepts of Chemistry. We have already discussed questions up to question number 29. So the first question for the day is question number 30, and the question says, what will be the mass of one carbon-12 atom in gram? To solve this question, let us first see what the molar mass of carbon-12 is. We already know that molar mass of carbon-12 is 12 gram. We also know the concept that 1 mole of this carbon-12 atom contains Avogadro number of atoms, that is 6.023 into 10 power 23 atoms. Now we can say that 6.023 into 10 power 23 atoms of carbon-12 weighs 12 gram. The question here is to calculate the mass for one carbon-12 atom. All we have to do is cross multiplication. Right? 12 divided by 6.023 into 10 power 23 gram, which is equal to 1.9927 into 10 power minus 23 gram. So this is the answer for the first question. Question number 31 says, how many significant figures should be present in the answer of the following? And then we have 3 sets of questions to solve. To answer this question, let us sum up these 2 rules which we have already learned. That is, in the case of a multiplication and division, the answer should contain the least number of significant figures as in the number from the question. For example, if we take a question like 2.5 into 4.334, we know that this number contains 2 significant figures and this number contains 4 significant figures. So according to this rule of multiplication or division, the answer should also contain 2 significant figures because this number has the least number of significant figures as 2. Similarly, when we are doing an addition or subtraction with the same number, let us take the same number. If it is an addition or subtraction operation, we are following the digit after the decimal point. So we know that in this number, we have 1 digit after the decimal point and here we have 3 digits after the decimal point. So in the answer, we should follow the least number of digit. So the answer should contain 1 digit after the decimal point. In this question, let us first try to calculate the number of significant figures in each of these numbers. So the first number here is 0.02856. From the rules of significant figures, we know that all zeros preceding to first non-zero digit are not significant. So we know these 2 zeros are not significant. Now we count the number of significant figures as 1, 2, 3 and 4. Now when it comes to this number, we have all non-zero digits, so all of these are significant. So we have a total of 5 significant figures. Again in this 0 is not significant, and then we have 1, 2 and 3 significant figures here. And in the last number, again we have 4 significant figures. From this we can say that this is the number that is having the least number of significant figures, that is 3. So our answer should also contain 3 significant figures. In the second question, we have 5 into 5.364. When we leave this exact number 5, we can say this number is having 4 significant figures as they are all non-zero digits. So the answer should also contain 4 significant figures. In the third question, we have an addition, and we know that in the case of addition and subtraction, the answer should have least number of decimal places. Now in this question, we have 4 decimal places for each of this question. So we can easily say that the answer should contain 4 significant figures. Question number 32 says, use the data given in the following table to calculate the molar mass of naturally occurring argon. And then we have a table wherein we are provided with the isotope, that is argon, and then the isotopic molar mass, and then the abundance. Now let's see how to solve such a question. To calculate the average molar mass, we have this formula which is m1x1 plus m2x2 plus m3x3 divided by 100. Now let me explain what these terms M and X1 is. From the question we are given the isotopic molar mass, which stands as this M, and the X stands for its abundance. Since we are given 3 sets of data, that is 3 isotopes of argon, this one stands for, M1 stands for 36 argon, M2 stands for 38 argon, and M3 stands for 40 argon. All we have to do is put the values in this question and find the average molar mass. So we have isotopic molar mass of 36 argon as 35.96755 into its abundance, that is 0.337, plus next we have 38 argon who has an isotopic molar mass, that is 37.96272 into its abundance, that is 0.063, plus isotopic molar mass of 40 argon, which is 39.9624 into its abundance, that is 99.600. The whole divided by 100. We get the answer as 39.948 gram per mole. So this is the answer. Question number 33 says, calculate the number of atoms in each of the following. And then we have 3 sets of questions. In the first question, we are asked to calculate the number of atoms for 52 moles of helium. Now we know that 1 mole of helium is equal to Avogadro number of atoms, that is 6.022 into 10 power 23 atoms. Now we are asked to calculate how much atoms are present in 52 moles. This is a very easy question. All we have to do is, if we know for 1 mole of helium, now for 52 moles, we have to simply do the multiplication. So we get 52 into 6.022 into 10 power 23 atoms, which is equal to 3.131 into 10 power 25 atoms. So this is the answer for the first question. Now for the second question, we are asked to calculate the 52 U of helium. This U is atomic mass unit or unified mass. We know that 4 atomic mass unit of helium is equal to 1 atom. Now let us calculate what is 1 atomic mass unit of helium. What do? We do the division, that is 1 by 4 atom. Now in the question we are asked to calculate for 52 atomic mass unit of helium, that is 52 into 1 by 4 atoms. Solving this we get 13 atoms. So this is the answer for the second question. Now in the third part we are asked to calculate for 52 gram of helium. We know that 1 mole of helium is equal to Avogadro number of atoms, that is 6.022 into 10 power 23 atoms, which is equal to its molar mass, that is 4 gram. Now let us calculate how many number of atoms are present in 1 gram. For this, we divide this Avogadro number of atoms by 4. So these many number of atoms are present in the case of 1 gram. Now in the question we are asked to calculate for 52 gram. What do? In the question we are asked to calculate for 52 gram. So we can say 52 gram of helium is equal to 6.022 into 10 power 23 atoms divided by 4, that is for 1 gram, into 52. Solving this we get 7.8286 into 10 power 24 atoms. Question number 34 says, a welding fuel gas contains carbon and hydrogen only. Burning a small sample of it in oxygen gives 3.38 gram carbon dioxide, 0.690 gram of water and no other products. A volume of 10.0 liter measured at STP of this welding gas is found to weigh 11.6 gram. Calculate empirical formula, molar mass of the gas and the molecular formula. In this question, we are first asked to calculate the empirical formula. In order to calculate the empirical formula, let us create this table wherein we are filling up the element, percentage by mass, atomic mass, moles of the element, simplest molar ratio and simplest whole number ratio. Now we know in this question it is clearly stated that we are going to talk about two elements, carbon and hydrogen. Now the next column is to fill up the percentage by mass. Let us first calculate the molecular mass of carbon dioxide. We know the atomic mass of carbon is 12 plus 2 into atomic mass of oxygen is 16. This gives us 44 gram. So we have calculated the molecular mass of carbon dioxide to be 44 gram. Now we can say that in 44 gram of carbon dioxide, it contains 12 gram of carbon. It's very clear because the atomic mass of carbon is 12. Now we know this. In the question it is given that the amount of carbon dioxide in this reaction is 3.38 gram. So we need to calculate in 3.38 gram of carbon dioxide how much amount of carbon is present. To find this answer, let us do the cross multiplication. So we get 12 into 3.38 divided by 44. This is equal to 0.9217 gram. So this is the amount of carbon present in 3.38 gram of carbon dioxide. Similarly, let us calculate the molecular mass of water, that is H2O. We know it is 2 into 1 plus 16. This gives us 18 gram. Now we know that 18 gram of H2O contains 2 gram of hydrogen. Now from the question we are given 0.690 gram of H2O. Now we need to find how much amount of hydrogen is present in this. To find that, let us do the cross multiplication. So we get 0.690 into 2 divided by 18, which gives us 0.0767 gram. So this is the amount of hydrogen present in 0.690 gram of water. Hydrogen and carbon reacting together, we can find the total mass of this compound as the mass of hydrogen plus the mass of carbon. Now we have calculated the mass of carbon to be 0.9217 and the mass of hydrogen as 0.0767. Adding them together, we get 0.9984 gram. And this is the mass of the compound. Now to calculate the percentage mass of carbon, all we have to do is, we know the mass of carbon. Now we know the mass of the compound. What do? We do the division. Mass of carbon, that is 0.9217 divided by mass of the compound is 0.9984 into 100. And this gives us 92.32 percentage. Similarly, the percentage mass of hydrogen can also be found, and that is mass of hydrogen, that is 0.0767 divided by mass of the compound is 0.9984 multiplied with 100, and this gives us 7.68 percentage. Now let us put these percentage by mass into this table. So we have calculated for carbon it is 92.32 percentage and for hydrogen it is 7.68 percentage. The next column is to calculate the atomic mass. So we know for carbon it is 12 and for hydrogen it is 1. To calculate the moles of element, all we have to do is we have to divide this percentage by mass with this atomic mass, and for carbon we get this as 7.69. Similarly, when we do the hydrogen, we get the answer as 7.68. Now the next column is to calculate the simplest molar ratio. To do that, what we do is we divide this moles of element with the smallest among these. Now we know these two numbers are almost similar. So when we divide this, we get 7.69 divided by 7.68 and 7.68 divided by 7.69. So this gives us 1 and 1. Since there are no decimal points in the last column, we can directly write this 1 and 1. From this table, we can write the empirical formula as carbon and hydrogen, that is CH. In the second part of this question, we are asked to calculate the molar mass of the gas. Now, from the question itself, we know that 10.0 liter of the gas at STP weighs 11.6 gram. This data is given in the question. Now, from this we can say that for 22.4 liter of gas at STP, we need to calculate the weight of the gas. What do? Again, we'll do the cross multiplication. So we can say 22.4 into 11.6 divided by 10.0. And this gives us 25.984 gram, which can be written as 26 gram. So we calculated the molar mass of this gas to be 26 gram per mole. In the third part of the question, we are asked to calculate the molecular formula. In order to calculate the molecular formula, let us first calculate the value of N. To do that, we know N is equal to molecular mass divided by empirical formula mass. Now, we know the empirical formula as carbon hydrogen CH. So the empirical formula mass will be atomic mass of carbon to be 12 plus atomic mass of hydrogen 1, which gives us 13 gram. And the molar mass we have calculated to be 26 gram per mole. Now we can put these values over here. So we get N as 26 divided by 13, which is equal to 2. Once we get this value of N, we can easily calculate the molecular formula as N into empirical formula. And we know N is 2 and empirical formula is CH. So we get the answer as C2H2. And this is the molecular formula of the compound that we were talking about. Question number 35 says, calcium carbonate reacts with aqueous HCl according to the reaction. And the reaction is given as calcium carbonate 2HCl aqueous state gives us CaCl2 in its aqueous state plus carbon dioxide gas plus water. Now, the question is to calculate what mass of calcium carbonate is required to react completely with 25 ml of 0.75 molar HCl. From the question, we are given 0.75 molar HCl. This means 0.75 moles of HCl is present in 1 liter of solution. Now, when we know the moles, we can calculate the given mass using the formula number of moles is equal to given mass divided by the molecular mass. Now, let us calculate the molecular mass of HCl. We know it is the atomic mass of hydrogen is 1 plus chlorine is 35.5, which gives us 36.5 gram. So this is the molecular mass of HCl. Once we get the molecular mass of HCl, by putting it in this equation, we can calculate the given mass of HCl in the solution as number of moles, that is 0.75 into 36.5. This gives us 27.375 gram of HCl. That is 27.375 gram of HCl is present in 1 liter of solution. To calculate the amount of HCl present in 25 milliliter of solution, what we have to do? We have to do the cross multiplication. So we can write it as 27.375 into 25 divided by 1 liter. When converted into milliliter, we get 1000. Solving this we get 0.6844 gram. So this is the amount of HCl present in 25 milliliter of the solution. Now let us look into the given chemical equation, that is where calcium carbonate is reacting with HCl giving us calcium chloride plus carbon dioxide and water. From this equation we know that 1 mole of calcium carbonate is reacting with 2 moles of HCl to give us this reaction. So we can say that 2 into the molecular formula of HCl is 36.5. So 73 gram of HCl is reacting with the molecular formula of calcium carbonate, which has atomic mass of calcium, that is 40 plus atomic mass of carbon 12 plus 3 into 16, which gives us 100 gram. So from this chemical equation we can say 100 gram of calcium carbonate is reacting with 73 gram of HCl to give us this reaction. We are asked to calculate how much amount of calcium carbonate will react with 0.6844 gram, because 0.6844 gram of HCl is present in 25 milliliter of solution. So we have to find how much amount of calcium carbonate will react with 0.6844 gram of HCl. Now to solve this question, all we have to do is the cross multiplication. Upon cross multiplication we get 100 into 0.6844 divided by 73, which is equal to 0.9375 gram of calcium carbonate. We have answered this question in 2 steps, wherein we have calculated first the amount of HCl present in 25 milliliter of solution of 0.75 molar HCl, and then using that information we have calculated amount of calcium carbonate that we require. So this is the answer for this question. Question number 36 says, chlorine is prepared in the laboratory by treating manganese dioxide, that is MnO2, with aqueous hydrochloric acid according to the reaction. And then we are given a balanced chemical equation wherein 4HCl react with MnO2 giving us 2H2O plus MnCl2 plus Cl2. And now the question is to calculate how many grams of HCl react with 5 gram of manganese dioxide. And then the atomic mass of manganese is given as 55 atomic mass unit. To answer this question, let us look into the balanced chemical equation. From this balanced chemical equation, we can say that 4 moles of HCl is reacting with 1 mole of manganese dioxide. Now let us calculate the molecular mass of both HCl and manganese dioxide. So we can say for HCl it is 1, that is the atomic mass of hydrogen, plus chlorine, that is 35.5, which gives us 36.5 gram. And for manganese dioxide, we know the atomic mass is given as 55 for manganese plus 2 atoms of oxygen. So 2 into atomic mass of oxygen, that is 16, which gives us 87 gram. Since 4 moles of HCl is reacted, we have to multiply this with 4. So we get 4 into 36.5 gram, which is equal to 146 gram of HCl is reacting with 87 gram of MnO2 to carry out this reaction. Now in the question we are asked to calculate the amount of HCl that we require for 5 gram of MnO2. Now it's very easy. We know all we have to do is the cross multiplication. Upon cross multiplication we can say 146 into 5 divided by 87, and this gives us 8.40 gram of HCl. So we have calculated that 8.40 gram of HCl will react with 5 gram of MnO2. This was the last question of the chapter, Some Basic Concepts of Chemistry, and hereby we have completed the NCERT solutions. If any doubts are there, please do comment in the comment section. Thank you.